1. Exposure. X. Definition. Measures the ability of X-rays or gamma rays to ionize air. It quantifies the amount of charge produced per unit mass of air. SI unit coulombs per kilogram ckg. Traditional unit Röntgen. R. Application. Limited to measuring ionization in air and primarily used in radiation dosimetry. 2. Kerma. Kinetic energy released per unit mass. Definition. Refers to the amount of energy transferred from radiation, photons, to charged particles, e.g. electrons, per unit mass of the medium. It is specific to the initial energy transfer from photons to charged particles. SI unit Gray Guy where 1 dial 1 J key. Application. Used in characterizing energy transfer in medical physics, especially in dosimetry and radiation protection. 3. Absorbed dose. D. Definition. The amount of radiation energy absorbed per unit mass of the material, e.g. as tissue. It represents the energy actually deposited within the material, regardless of the initial energy transfer process. Unit SI unit Gray Guy. Traditional unit rad, 1 rad il 0.01 J. Application. Widely used in evaluating biological effects of radiation exposure. Key relationships. Kerma versus absorbed dose. Kerma describes the initial energy transfer, while absorbed dose accounts for the energy actually deposited. In low-density materials, like air, kerma and absorbed dose are nearly equal. In tissue, absorbed dose is less than kerma due to scattering and secondary effects. Exposure versus absorbed dose. Exposure applies only to air and is a measure of ionization, while absorbed dose applies to any medium and measures deposited energy. Conversion factors depend on the material and radiation type.